Boa noite, pessoal. Cristiano Linux Main na área, apertando vários botões, né? Girando vários pratos. Estou aqui em meio a TDC, Cloud Native Talks Brasil. Aqui do meu lado, né? Eu posso até facilitar, trocar ele de lado, assim, ó. Aí fica assim, ó. Agora do meu lado direito, o senhor Paulo Simões. Senhor Paulo Simões, boa noite. O que o senhor tem de...
Boa noite, Cris. Boa noite a todo mundo.
Hoje nós temos aí, né, uma palestra sobre o Linkerd, com o Charles Pretzer. Qual é o nome da empresa, senhor Paulo?
Buoyant.
Viu? Saiu bonito agora, hein? Galera, só um recado rápido, a gente já está, inclusive já falou com o ETH0 e tudo. Nós sabemos do objetivo central do projeto, de levar sempre conteúdos em português para vocês, mas especialmente essa palestra será em inglês. Depois a gente dá um jeito de fazer uma transcrição dela em português, né, uma legenda. É mais para aproveitar a oportunidade, e se vocês sentirem alguma dificuldade aí em relação à pergunta, não sei o que, pode escrever no chat em português, que o Paulo pergunta em inglês e tenta passar um resumo em português para vocês, então fiquem à vontade. É mais para a gente aproveitar um palestrante internacional que se dispôs a vir falar de uma tecnologia que está aí super crescente, né, senhor Paulo Simões? Então, eu vou deixar o senhor Paulo Simões com o Charles aqui, vou trazer o Charles entre nós, e assim segue o show. Beleza, senhor Paulo?
Beleza, Cris. Beleza, vamos lá. Pessoal, uma breve introdução, né? O Cristiano já começou a falar. A nossa oportunidade é Charles Pretzer. Ele é Field Engineer, né? Engenheiro de campo da ABN, que é uma das empresas mantenedoras, a principal empresa mantenedora do Linkerd. E hoje ele vai falar para a gente sobre como ter a visibilidade multicluster, né, com o Linkerd. Isso é um item, né, uma característica muito bacana, e a gente não podia perder a oportunidade de trazer o Charles para conversar com a gente, né, expor esse assunto. Como o Cristiano falou, a gente vai tentar ao máximo colocar depois legenda para vocês, mas, pessoal, aproveite, a gente está aqui para ajudar. Charles, thank you so much for joining us today and talk for us about Linkerd, about multi-cluster visibility. It is I'm very proud and honored to be here with you, and the show is yours. Thank you so much. I'm going to backstage and see you. Thank you.
Yeah, hi. Thank you, Paulo, for that nice introduction. And thank you all for having me. I really wish that I spoke Portuguese so that I could effectively communicate some of the concepts that we have here today. And I know that it's really important for you and your community to be able to experience all the technology that's available in your local language. So I really appreciate you being patient with me, and I will do my best to speak slowly and clearly as we go through the presentation today. So, Paolo, I really appreciate you reaching out and making the effort to bring me into your community here. You and I have talked about doing a series of presentations, and so today we're going to start with multi-cluster service mesh with Linkerd. This is more of an advanced topic, so there are a couple of things to take note of here. First of all of my contact information is at the end of the presentation. I'll be sure to share my slides with you so that when you, after this presentation, you can get a hold of me and you can ask me any questions that you want about this particular presentation. As we go forward, and if we do additional presentations, we'll take a step back from some of the more advanced topics and go into just some of the basics about Service Mesh and about Linkerd. And I'll also be covering some of those here in this talk as well. But for the majority of this conversation, we'll be talking about how to span multiple Kubernetes clusters with the Linkerd Service Mesh. So with that, let's get started. I'll share my screen here, and you should be able to see, hopefully you can see my slides. Okay, so our agenda for today will be we'll do that overview of the Service Mesh concepts specifically, and how Linkerd implements them. And then we'll talk about some multi-cluster concepts, things like why would you want to have multiple Kubernetes clusters, and how do you manage multiple services across those different clusters and make them appear as if they are all on the same cluster. Then I'll do a demo for you showing you how to deploy Linkerd, the Service Mesh, as well as the multi-cluster aspect of it. So I've set up two clusters, cloud-hosted clusters, that we'll use as we go through this demo. I'll show you when we get to the demo that they are brand new. There's nothing on the cluster, so there will be some time for us to talk while some of the components are installing, and more importantly, while the IP address is provisioned for the clusters to communicate with each other. And when we get to that point, I'll explain exactly what's happening. And then if we have time, we'll get into splitting the traffic across the clusters. So with that, we can jump right into the Service Mesh overview. When people ask me what a Service Mesh is, and it's interesting the evolution of the questions that we get from people. So probably 2 or 2.5 years ago, people were wondering, what is a Service Mesh? And now we get questions more like, do I need a Service Mesh, or how can I get a Service Mesh? But we'll start at the very beginning and say, what is a Service Mesh? In this very simple slide, you see that we have a distributed application that makes no opinion about a cluster or anything. All we know is that there are 3 services, A, B, and C, which are communicating with each other as service A receives traffic from the outside world, from the internet, or from some client that is external to the application itself. The reality of a real-world distributed application is that you have multiple services, multiple instances of multiple services, and those services can communicate with other services. They can communicate with things like databases, where you see service X here talking to a database, or they can make calls to external APIs, like you see with service Y in the corner over here. So what's in addition to this, the complexity that we've added is that there are, again, multiple instances. So you see that A has multiple instances of A and multiple instances of B and C, and those are all communicating with each other in a way that allows for optimization of resources and for orchestration. And this implies that you need things like load balancing across those instances. So to put that into a very concrete example, let's say you see service A is communicating with service B. It sends traffic to service B. If service A sent traffic to only one instance of service B, what would end up happening is that one instance would quickly become overloaded with all the requests, while the other instances of the services, the other instances of service B remain idle. And so this is one of the challenges of a distributed system, and this is one of the reasons that the Cloud Native Computing Foundation was founded, in order to address these issues of resource management and being able to build applications that don't require you to physically own the servers. You can use this reusable infrastructure. So I imagine since you all are here, you're part of the CNCF, you're familiar with the concepts of cloud native. And so again, if there are questions about that, you can put them into, I think there's a comments section here. And also, again, I'll have my contact information at the end so that you can reach out to me. So in this example of Service Mesh, we see, or sorry, of this application, we see all of these components communicating with each other. Service Mesh provides 4 key concepts that I'll go over in a second here. We've got observability, security, reliability, and traffic management. And none of those are represented here. And that's by intention, because in the next slide, we want to be able to understand what happens when things go wrong in your application. So let's say that you have no service mesh in place, and you have external API requests that are being blocked, or your database is just overloaded, it's locked maybe on a transaction, or you released a new version of the service B and it's really slow. And all of these things will impact the performance of your application. So without a service mesh, without the observability piece that we've discussed already, it can be very difficult to determine when these things are happening. And what that boils down to is one key component for measuring performance is mean time to detection, which means the mean time that it takes to understand that your application is behaving poorly or that there's an error in the application. And the knock-on effect of that is that you've got the next metric, which is mean time to resolution. So in theory, in theory, the faster you can get to mean time to detection, the sooner you can begin to move towards mean time to resolution. And that's what really the main key for this observability piece provided by Linkerd. So let's jump into what that looks like, again, back on our smaller scale application. So when we take it back to our very simple application here, distributed application, we now see that the services A, B, and C are not communicating directly with each other like they were previously. Instead, they're communicating with each other through these proxies. And these proxies are what comprise the data plane of a service mesh. This involves a pattern called the sidecar pattern. And specifically for Linkerd, what this means is when you create a pod, either through a deployment or through like a stateful set or a daemon set, Linkerd, and you inject the Linkerd proxy into that resource. When the pod is created, Linkerd, the control plane, injects the proxy as a container into that pod. So the very simple case is if you had one container in your deployment, you'll now see that there are 2 containers in your deployment, one of which is the Linkerd proxy. And there are a lot of things that happen underneath during the initialization of the proxy. One of those is that, or sorry, the initialization of the pod. And one of those is that the IP tables are rewritten such that all the traffic that comes in is routed directly to the proxy, and then the proxy then sends the traffic directly to the service, and vice versa. The service, when it sends traffic out, so when service A wants to communicate with service B, it sends that request that goes through the proxy, and then the proxy handling the request for B gets that traffic and sends the request to that service. So as we unpack this, you can begin to see with these proxies being in the place that they are with their relationship to these services, there's really a lot of information and a lot of useful activities or useful functions that we can take advantage of. And we'll talk about those right after we talk about the control plane. I mentioned that when the pod starts up, the proxy is injected into the pod. And along with that injection comes different pieces of configuration for each of the proxies that are unique to the clusters. A really good example of this would be if, when you're using Kubernetes, you have specified a custom cluster domain. Typically, or by default, the cluster domain is service.cluster.local, but it's entirely reasonable for you to change that to whatever you want internally. So the proxies need to be aware of this, and this is done through the control plane. When you install the Linkerd control plane, you can specify the cluster domain, and this is just one of the many configurations that are possible. It's worth mentioning now that the user experience for Linkerd is meant to be extremely lightweight and easy. So while you can configure many of the proxy options, the team has gone through a lot of effort to make sure that those options are set by default so that you don't have to manage them on your own, and so that those defaults are sensible and that they will work for your application straight out of the box. And we'll see that as I install Linkerd through the demo. But the main takeaway here is that there are multiple components in the control plane that are used to configure the values in the proxy, which then begin to manage the traffic between each of the services. As I mentioned, the proxies sitting in the position where they are allow for really these four key concepts of a service mesh. You've got observability, security, reliability, and traffic management. The observability piece comes in because when a request is sent from one service to the next, and that request is being handled on both ends by the Linkerd proxy. And what that means is the proxy, the request is sent by a service, it goes through the proxy, and then it is sent to another proxy, which then sends it back to a service. So if we look at this example again, when A communicates with B, it's going through these two proxies. So what that allows us to do is collect these actionable metrics. So we can get things like the success or error rates. So if service B results in an error, we can report on that. We can look at the requests per second. We can look at the latencies. And I'll show you some of these metrics that we can collect in the demo. But this is really, again, one of the core concepts behind Service Mesh. And one of the main reasons that the folks at Buoyant, the Linkerd team, created the Service Mesh is because it solves this real-world problem of being able to get these metrics in a transparent way that you don't have to modify your application code. One question that we often get about these proxies being in what we call the fast path or the data path is that, do they add latency? And of course, anything that you put into the data path is going to add latency. Our proxy, the Linkerd proxy, is a custom-built proxy that's written using Rust, which is a fairly modern or new programming language, and it is a compiled language that is both memory and type safe. And so what that allows us to do is to write very performant code that uses, it's lightweight in its memory consumption, and it handles the requests very, very quickly. We do have some quantifiable metrics, but I believe the RSS consumption is 20 megabytes of memory, and CPU is, I forget what it is off the top of my head, but by using Rust and by investing in the Rust ecosystem, we built this custom-built proxy that is designed to be used with the Linkerd control plane in order to be highly performant and as it handles requests. So the next piece is security. And again, it's only a small second when we talk about observability and security and which is more important as a concept. So again, going back to our example here, what the Linkerd proxies do is when they communicate with the control plane, they request a certificate from the control plane. The control plane itself has a certificate authority, which is configured to issue certificates. And you can provide your own certificates to each of these when you install Linkerd, which I will end up doing today as we go through the demo. When the proxies send that certificate signing request to the control plane, they get a certificate back. So that means when the proxies are communicating with each other, they're using these certificates that are each individually signed by the control plane, which sets up the stage for mutual TLS. And that means that there are two very important things that happen. When the proxies communicate with each other, they start with a handshake with one to the other that says, I'm the proxy for service A, here are my credentials, and same for proxy B. Proxy says, I'm the proxy for service B, here are my credentials. They can confirm that those credentials have both come from the control plane so that they are from a single source of truth. And then that's the validation piece. And then once they've established that each is the identity of the other one, they can then use that certificate to encrypt the traffic. So if we go back to the scenario where services A and B and C are all communicating with each other directly, unless the code is written for mutual TLS, usually those communications take place all in plain text. But with the Linkerd service mesh in place, or with the Linkerd proxy in place, since we have those certificates that can encrypt the traffic, now anything that goes across, any traffic that goes through your cluster, that what we call east and west traffic, is now encrypted. And this is really powerful for multi-tenant environments. So if you have multiple tenants in your Kubernetes cluster, it's also useful for certain industries like banks, which have end encryption or require traffic to be encrypted by default, all from in the back end as well as in publicly exposed areas. So again, the proxy being where it is allows for that observability and the security of the communication. Thirdly, we have reliability. And a minute ago, I gave an example of how service A can communicate with service B. And when it gets an error from service B, it can record that error as an error occurred. With the Linkerd service mesh, we can configure retries and timeouts. And this is great for situations when you have a temporary error in one of your services. So let's say you send a request from service A to service B. Service B gives you an error, but it's not a systemic error. And so the proxy can try that request again. And what this does is it improves your overall success rate for your application. Even though there was an error, the request gets sent again. And again, this is specifically for GET requests. Linkerd won't retry post requests because in order to remain performant, we can't store HTTP request bodies in the proxy. So the point is, by using retries and timeouts, as well as a sophisticated load balancing algorithm, we can improve the reliability of your application. And finally, we have traffic management. And that's the one that I think might be most obvious in this particular demo when we talk about the multi-cluster communication. What we're doing is managing the traffic between two clusters. Now, you can also manage the traffic within a cluster, and we are leveraging that same functionality to split traffic or manage traffic within a cluster to then expand across multiple clusters. And I think that'll become clear as we go through the demo here. So with that, I'm pausing to check to see if there are any questions in the comments section. I'm happy to answer these as we go along. As long as I don't see anything in there, I will continue to go through this, our presentation here. So all of those concepts that I just discussed, observability, reliability, security, and traffic management, they're all accomplished transparently. And what that means is you don't have to add anything to your service code in order to get the load balancing. You don't have to write code to implement mutual TLS. Linkerd, because it's proxying all the traffic, is going to manage that for you. You don't have to send your own metrics to some like Datadog or Prometheus or something. Linkerd collects those metrics and exposes them to any Prometheus instance that you have available, as well as its own Prometheus instance, so that you can see the metrics without having to instrument your own code with those libraries. So that's really powerful. It means that you as an application developer or the application developers on your team, they can write less code. Less code means less bugs. So there are a number of advantages to this by having these transparent proxies being added to the pods as containers and managing the traffic. So that's the service mesh concepts, the high level, like, again, we go back to that question, what is a service mesh? Service mesh provides security, observability, reliability, and traffic management. And that will then take you into the question of, do I need a service mesh? And that is really up to you. So based off of those features that I just discussed, you can look at your application and say, well, you know, it might be very useful to have our success and error rates or our latencies as we roll out new pieces of code. So again, this is something that I'm happy to discuss with anybody. We have our Linkerd Slack channel, which I'll share with you at the end here. But I spend a lot of time working with folks in my role as a field engineer, working with folks to make them successful with Linkerd and help them to really understand if there's a problem that a service mesh can solve, we can explore if Linkerd is the right tool for that. So one of the questions that we got probably, I guess 18 months or so ago was, does Linkerd support multiple clusters? And what that means is if you've got multiple Kubernetes clusters, say in different regions or different data centers, or even in the same data center, but across the room from each other, and you want to leverage the resources, the CPU and memory resources, and even storage resources that are available to those clusters to run your workloads, how can you make it seem as if those multiple clusters are one cluster from the perspective of a service mesh? And that's what we're going to go into now. So there are lots of ways to connect multiple Kubernetes clusters. Linkerd's approach is to leverage as much of the existing infrastructure and architectural patterns that are already in place by Kubernetes. So again, Kubernetes first is that the services should appear as Kubernetes services. And I'll show you what that means as we go through the demo. The short version is when I deploy a service on one cluster, and when I deploy the same service on each of multiple clusters, and in this example, we'll use just 2 clusters. How can I make those services look the same as if they're, again, on the same cluster? And so we use Linkerd for that. Another really key architectural component is that there's no single point of failure. So the trade-off there is that the Linkerd control plane gets deployed to every cluster. But that's okay, because now that means that if one of those clusters should fail, you still have a control plane that can collect the metrics, that can provide you with all the details that you need without having to have to spin up another cluster with the service mesh control plane. And so we can compare that to other implementations of service meshes where they do have one centralized control plane that runs on a single cluster, and then each of the other clusters has agents in them. The Linkerd approach is different than that. It, again, makes all the clusters appear the same, and the services, there's, again, no special cluster that is the control plane cluster. There's transparency. Again, this is slightly different than the transparency that we talked about with adding the Linkerd proxies to your code, but the applications don't need to know whether the service is on the same cluster or on a different cluster. All it knows is that is an endpoint where it can send traffic, and it will send that traffic there, and that's all it needs. And there's no reliant on any kind of network. So you can have a flat network structure, or you can have you can use your different network providers, and the only thing that matters is that the two clusters can talk to each other. So this is the Linkerd architectural approach to multi-cluster. And as we go through the demo and these next few slides, I think it'll help to explain some of this here first. So the first thing that we see is that we have two clusters. We're going to call these East and West to represent the different like regions or zones, availability zones. In these clusters, we will eventually install a test application. It's called PodInfo, and it will be identical in both clusters. So one of the reasons something that's worth mentioning is, why would you want to have multiple clusters? And there are a couple of reasons. A lot of them revolve around traffic migration, or traffic management. So traffic migration, canary deployments, and failover are all kind of along the same vein of traffic management, right? So if one of your clusters fails and you want to shift all the traffic over to another cluster, that's what this can be useful for. If you want to have different environments, so this is a less common use case. I've only seen it used a couple times. One is so if you have a staging environment and a production environment, you can mirror those. It gets a little tricky when you're managing the traffic there, so that's why we don't see this particular implementation very often. Canary deployments is a very common use case, and so if you have a cluster that runs just your canary deployments, or even if you want to run canary deployments across both clusters, this will allow you to do that through the traffic split functionality. So there are a few different reasons why people would want to use multiple clusters. Most of it is around redundancy and reliability and availability as well, to ensure that requests that come into a specific zone stay in that zone, and vice versa. One of the steps that we're going to see in the process is linking the clusters. There's a command called Linkerd multi-cluster link, and this gets into the security piece. As I mentioned, we are leveraging just the resources that are available inside of a Kubernetes cluster, so there are no custom resource definitions for this particular piece. What ends up happening is, when you link a cluster, it creates a service account which sends a kubeconfig secret over to the remote cluster, and then there are two components that we'll see inside of the Linkerd multi-cluster installation. You've got your service mirror and your gateway. I've mentioned the gateway a little bit already. We'll see that in practice in just a second here. So the service mirror communicates with the Kubernetes API server on the remote cluster. In order to do that, it needs a kubeconfig secret. And this is very similar to, or actually this is exactly the kubeconfig secret that you have in your environment, or it's like that one when you're using kubectl to run commands against the API server for your cluster. This is the same concept here. There's a kubeconfig secret that the service mirror uses to communicate with the API server of the other cluster. So this is one of the ways in which security is enforced between these two clusters, mostly to ensure that nobody who is acting maliciously, or actually, I'll take that back, mostly to make sure that only the Linkerd components are communicating with each other across clusters. So another part of the security mechanism is when we install Linkerd, I mentioned that we have those certificates that are issued to the proxies. So there's the certificate authority, which is known as the identity component in Linkerd in the control plane. We specify a certificate and a key to install during the installation process. And that certificate and key is used for that mutual TLS that we talked about. Only last time when we talked about it within the context of a cluster. What we're talking about in multi-cluster is the same concept. We've got those certificates that are doing that same handshake with each other. Specifically, the gateways are talking with each other. They trade their certificates. They verify that they come from the same trusted source, and then they can begin to communicate with each other through encrypted traffic. Furthermore, these points that are exposed, the ports that are exposed, these endpoints, for these two services to communicate with each other are require that you have the certificate. So if anybody tries to send requests to these clusters or to these endpoints, they'll be rejected automatically because they are not sending over the appropriate credentials. So I make a strong point of this because there are folks who are concerned, and rightly so, about exposing endpoints to the public internet for access to their cluster. By using these certificates that are assigned during installation, we can ensure that that security is very tight and that there's no way that anybody can access without having that certificate, which they shouldn't be able to get. Okay, so what we're going to see as we go through this demo, we're coming up to it, I promise. What we're going to see is that we're going to install the Linkerd control plane. We'll install the Linkerd multi-cluster components, which I alluded to just a second ago. There's the Linkerd service mirror and the Linkerd gateway. And then we're going to deploy this test application, which shows us, if I do this right, it'll show us that we're communicating across clusters that are in these different data centers or different spaces. And we'll see that the traffic going between them, we'll be able to measure the latencies for the services that are on the remote clusters, which is really cool. So this is just, again, an extension of that. As I mentioned, we have what's called a traffic split. Oops. And that's what this TS is here in the corner. So what this ends up doing, and this is part of the traffic management piece that we talked about. So when a request comes into this front-end service, it's going to recognize that it can load balance across what we see as the pod info and pod info east services. And this will make sense once we do the deployment. When we specify the traffic split, we can specify the weight by which each of those services should get that traffic. And then we'll see the traffic be split across the local cluster, the service in the local cluster, and the service in the remote cluster. So I'll pause for a second here, just in case anybody wants to ask a question in the comments part. But if not, then we will jump into the terminal here. Oops, okay. Okay, so let's move some of this out of the way. Oops, I should turn off my messages here, shouldn't I? Okay, give me just 1 second, please. There we go. Okay, that should do it. There we go. Okay, back into this terminal. So what I've got here, and these are all scripts that I'll share with you. Let's go into, take a look at the Linkerd documentation. So this is something that you can follow along with if you're interested. I'll put this into the comments section. We're going to look at features and I think multi-cluster communication. Here we go. Getting started with multi-cluster. So what I've done here is I've taken, let's see. Oh, I don't think I can add a comment here. That's okay. All right. Well, this is the step-by-step walkthrough. And so I've taken all these steps that we see here and I've put them into some scripts. And again, these will be committed to my repository so that you can try them out yourself. The first thing that we're going to do is run a pre-check on the cluster. So if we look at pre-check linkerd.sh, there's only one, well, the important command that's being run here is this linkerd check -- pre. So there's a linkerd check and linkerd check -- pre. All this is going to do is go through, and it's looking again at, we've got a west cluster and an east cluster. And
Charles.
yeah.
Sorry, can you increase a little bit your phone? Just a little bit.
Yep. Give me 1 second here.
Thank you.
Thank you for telling me. Oops. Let's see if this works.
Very good. Excellent. Thank you so much.
Yeah, no problem. No, that's okay. I'm glad you reminded me of that. Okay, so what we can see is that this we've checked the cluster, and this is both the east and the west clusters. And just to put that into context, we'll do kube-config get clusters, and we have east and west. Or if I do get context, we have, again, east and west. So I'm working with just 2 clusters here. So the first thing we did was we ran linkerd check -- pre, and again, this is a pre-check that runs, and it makes sure that you can create all of the resources. So those are service accounts, deployment, cron jobs, config maps. You can read the secrets. It's really just a permissions check and capability check, for example, to make sure that you can communicate with the Kubernetes API. So we know that that works. Let's look at the next script, and that's just to install linkerd. So let me do this here. Here's the important part of this. We are going to run the linkerd install command. I've already generated my certificates, and so these are the certificates that I mentioned to you that are going to be used for that for the mutual TLS. So I've created those. We're going to install linkerd control plane on both of the clusters, the contexts. And then we'll do another check, except this time it'll be without the pre-flag that you saw just a second ago. So I'm going to kick that off, and then I'll start talking as that deployment process takes place. Before I do that, though, I want to show you that there is nothing. These are brand new clusters. So all they've got are the kube system pods on them. So I've just set these up not too long ago. Okay, so let's do install linkerd.sh. Oh, I did see a little error there. Let's see if we can figure out what that is. Okay, I know what that is. It's trying to do a check before it was ready to be checked. So what we're seeing here is, again, I mentioned that one of the pre-check commands was to make sure that we could install we could deploy the resources like services, secrets, config maps, role bindings, all of these different Kubernetes resources. So now I should be able to do that linkerd check command. And I'm not sure which context this is by default, actually. So right now the default context is east. So linkerd check east. So it's going through, and we see very quickly that the control plane was properly installed on the east cluster. Let's verify the same for the west. We still got the controller pod starting up, but that's okay. While that's happening, let's look at the pods of the Linkerd control plane, and I'll walk you through each of those. We're going to look in the east context because we know that that one is up already. So we have the controller component, and this is used for UI. Destination, which is used to determine the endpoints. Grafana shows us some dashboards, and I'll show you how each of these is used. The identity service is the one that I mentioned earlier that is the certificate authority. So this generates certificates and issues them to the proxies. Prometheus is a local instance used for collecting metrics. It's meant to be federated with a larger instance of Prometheus, a production-grade instance. The proxy injector is responsible for injecting the proxies into the pods based off of an annotation. In TAP and web, well, I can show you the web component now. Linkerd comes with a dashboard, and what that looks like, let me make this bigger for you. So the Linkerd dashboard, and this became available as soon as the control plane was available, shows me all of my namespaces as well as the pods that are part of the Linkerd service mesh. The interesting thing here is that the Linkerd control plane itself has the Linkerd proxies injected into it, which means that it is part of the service mesh, and we get to see all of those metrics that I discussed earlier. So I'll make this a little bigger again. We can see that the success rate is 100%. We've got 1 request per second. Prometheus makes many more requests per second because it's scraping the metrics endpoints from the proxies, and we can see the latencies involved with each of those. So we should have the context in the West is all good. And we can see the same control plane pods there as well. So I show you this so that you can see that the clusters are truly identical in terms of the control plane components. So let's move on to the next step, which is to install the multi-cluster piece. If you recall from the slides that I showed you, there's a link step, which we'll do next. The first thing we need to do is to deploy the multi-cluster control plane components to the cluster. And so these get installed into their own namespace. It's called linkerd-multicluster. And part of the script here is to check while the startup of those pods happens. So again, you'll see that there are 2 components inside of the Linkerd multi-cluster namespace. One is the service mirror, and the other is the Linkerd gateway. So here we can see that, let's see, this is, let's see if I can figure out which cluster this is. This is probably the West cluster. It's the East cluster. So in the East cluster, we can see that there are these 2 pods that are running, the Linkerd gateway and the Linkerd service mirror. So this is what allows us to communicate between the 2 clusters. The other thing we need to look at, and this is what takes a little bit of time to be allocated, is the public IP addresses for the Linkerd gateway and service mirror. So here we can see that it's pending. This can take a few minutes, so we can go through and talk about some of the other, other aspects. So yeah, let's look at what these 2 are actually doing. So, oops. So what I've done here is we're going to take a look at the logs for the service mirror. And here we see it's the version of Linkerd, and it's starting an admin server, and more importantly, it's starting this cluster config watcher. So when we link the two clusters, what ends up happening is there's an annotation that gets added to the, it creates the service account that I mentioned and the kube config, and it sends it over to the other cluster. Let's see if we have our IP addresses yet. Nope, still pending. Okay, so let's look at the logs for the gateway. So those are the service mirror logs. Oops, I spelled that wrong. Multi-cluster. There we go. So we'll look at the gateway here, and the gateway is the one that's responsible for the communication between the clusters. Interesting. So there's no output just yet. That's because there's no communication between the clusters. So all we're waiting on now is those public IP addresses. There we go. Okay, so we've got those, and what that means is we can look at the script to link the clusters. So again, this Linkerd CLI is something that I had already had installed, and it's got multiple commands. Here we've got the Linkerd multi-cluster command and the link subcommand. So what this is saying is link from the east cluster, link the west cluster. Did I do that right? Yes. Yeah. And so it also assigns the cluster name. So we're linking east to west, which means that west will know about the east cluster, but the east will not know about the west cluster. And I'll show you what that means with these other commands that we have available to us. So let's run that. Okay, so the link command happened very quickly, and this is the only output. Remember that I said that we're creating a secret with the kube config in it, and that's what was created. So if I do kube control get secret -run Linkerd multi-cluster context equals west, we will see that here we have these cluster credentials that are on the west cluster. So now it can communicate back to the east cluster. So I hope that that makes sense. Okay. And then we had, let's look at that 3 command again, because there was some output that I didn't see. So look at the, and you can use MC as shorthand for multi-cluster, so you don't have to type as much. So great. Here we see from the west cluster that it knows about the east cluster, but it's not alive at the moment, which is interesting. So let's see if we can get any information out of. Here we go. So for some reason it thinks the gateway is not alive, and this is where we can go and look at the logs for the gateway pod. Here we go. Oops. Let's do this. So there's nothing in the west. So let's see if the east, that pod will tell us anything. And there's no output there either. Okay, that's okay. So the service mirror, or sorry, the gateway is actually just an instance of NGINX with the logging turned off. We should be able to. Okay, so we'll move on because we're going to deploy our application. still not sure why this is showing that it's not alive yet, but let's look at the service mirror just to be safe. There we go. Part of me thinks this might be like a firewall issue, but I'm just checking that now. Okay, so it is saying that this is unhealthy. Linkerd Gateway East, okay. Load balancer, it's trying to communicate with 4181. Okay, let's go ahead and install the application. So we're adding our test services. Those were there's a front end and a pod info. And this is an application that's written by a gentleman who works at Weaveworks. His name is Stefan Proden. And this is really a mechanism for testing, splitting traffic, and for using Flagger for canary deployments. We're using it in this case to test out the communication between our two clusters that are unrelated to each other. So this will be, once all of these pod infos, once each of these deployments is complete, it'll roll them out to the other cluster. And in the meantime, let's see if we can figure out, oops, nope, never mind. Still trying to figure out why that cluster is not available yet. I'm thinking I may have linked them the wrong way, but we'll check. Okay, so these pod infos are almost rolled out. It should be, so if there's a firewall in place, that would mean that the gateways couldn't communicate with each other. So that's one thing that I think might be happening. Let's see, so now we're port forwarding. And let's see. Yeah. So yeah, we're port forwarding. So if I go to localhost 8080, I should be able to see my application. So this is the pod info application from the west. Right now, we're not splitting traffic, so this is only going to the west pod. So one thing I want to take a look at is the check. Let's see what happens if I go to the east cluster. So there's nothing there. There's only a gateway on the west cluster, and it's still not alive. We can still see that it's a problem connecting with the gateway. Linkerd Gateway Health. Okay, so there's no logs coming out of there. So it can't get to that endpoint, which is interesting. And I wonder if it has something to do with this. What I can do is we can look at the context, the services in east for the Linkerd multi-cluster. And we have our, so gateway is there. It's got an IP address and 4181. So I don't expect this to work. I just want to see if I'll get any kind of response back. Yeah, okay. Empty reply from the server, which I think is okay. Oops. The multi-cluster. Oops. let's look at the multi-cluster components in the East context. And this is beginning to look like it's not going to work for me today. I think I didn't set this up right, or the demo gods are upset with me. Okay, let's see. Right, so there's nothing coming in. Oops. We gotta do context equals east. And again, we're getting nothing out of there. So that's interesting. What I'm trying to debug here is the service mirror is making this call to Linkerd Gateway East. It should be, and that is a service in the Linkerd multi-cluster component. So let's look at the details. This is a service. Oops, there we go. The multi-cluster. Okay, so here are the interesting annotations that are added when we create, or when the service is created. So you've got a mirror gateway identity that's created, and so that's Linkerd Gateway. This is what I would expect it to be. It's the service account for this Linkerd Gateway service. It's specified as being a Linkerd multi-cluster gateway. The probe path is health, which is right. So, and we specified that it should be able to get to 4181. So I think that this is a firewall issue in the hosting provider. But let's see. Export services. Let's try this just to see if it makes a difference. What this export services command does, and again, this is the relevant command, it is going to export this service named pod info, and it's basically just going to annotate the service. This is a single line command that you could use to create your own service. Oops. So in our, actually, let's use, oops, okay. Here we go. We have a pod info service. Oops. We want context equals east. And where's my, oh, there it is. Okay. Pod info east is a service that we just created. So if we look at the YAML for this, oh, that's what we did. Okay. Again, Linkerd uses annotations to ensure that these services get mirrored properly. So the relevant annotations here are the remote gateway name and the remote gateway namespace, and that is Linkerd Gateway and Linkerd Multi-Cluster. So this is what was added to that service in order to export it for multi-cluster. So let's look at, let's see if we can get our gateways again. It's still not working. I'm going to try one thing real quick because I may have gotten this backwards. So, oops. I may have linked them incorrectly. Let's just take this. There we go. So what I want to do is the context equals west. East. Okay. So again, we see the credentials were created, and what I'm going to do this time is go to the East gateway and see if it's still not happening. So that's why I think that this is happening on the other side. There's a firewall between these two services. So, boy, that really messes things up for us. Okay, so let's look at the rest of the services here. So we did the export services. One of the things, or the next thing that we would do is look at the dashboard again within the context of these services. So now if I go back to the dashboard, I should see that we have a test namespace, and there are no cron jobs there, but if I go to pods or deployments, I can see that, again, this must be our East context. So it's more interesting if we do the dashboard. Probably have to, stop the other dashboard. So okay. Great, okay. So one of the things is that our pods are not meshed here. I don't think that's actually causing the issue, but what I can do is show you how we annotate those pods. So let's look at, we'll do this, cube control, annotate, namespace, test, linkerd.io inject equals enabled. So what this is going to do is add the linkerd inject annotation to the namespace. So cube control get namespace test -o YAML. And again, it simply added this annotation. So that Linkerd proxy injector component that I mentioned earlier detects that annotation and will inject the Linkerd proxy into those services. So here we see that these pods don't believe they have the Linkerd proxy injected. This one, the containers in this one are also load generators as well. So if I do, let's do cube control, let's restart these deployments. And if we do that, we'll see, interesting, it's not injecting them at all. Okay, well, like I said, I think I made the demo gods angry for some reason. Because if we do Linkerd check, everything is fine except for the gateways. So we should be getting these pods injected as well, which is interesting that they're not being injected. So yeah, the other parts of the control plane that I mentioned earlier are the Grafana dashboard as well. So we can get to that through the Linkerd dashboard. Oops. And so we're opening up the same namespace here, the same dashboard here. If we go over to click on the Grafana icon, what we see is that we have these dynamic dashboards that are created anytime a deployment is injected with the Linkerd proxy. So in this case, we can see that we have requests and the P95 latencies for the pods in the Linkerd control plane. just to take a closer look at that, we can also use the Linkerd stats command for the Linkerd namespace. Oops. Yep, I meant Linkerd stat. So when we do that, we can see, again, these are all the same metrics that I showed you previously in the dashboard. They have all of your P95, P99 latencies. We can see the number of connections. If you want to see the TCP level metrics, then we can see the number of total bytes read and written. And these are different from the golden metrics for the HTTP metrics, which are success rates, error rates. So yeah, it looks like my multi-cluster demo is failing, and I need to figure out why. I don't think it's fair for you all for me to debug it here, but I'd love to answer some questions that you all have. I jumped into the dashboard. We can go through that a bit more if you want. I can show you some of the other commands. I'm really confused by something that's going on here, but yeah, are there any questions that I can answer in the meantime? Oops. I'm just going to deploy another application quickly to see if I can get this to work. Interesting.
Hi, Charles. We don't have questions yet.
Okay.
Wait.
Well, yeah, sorry about that. That was, you know, that's the problem with live demos. I will, again, I have this repository available, and so I'll share it with you all so that you can go through the demo yourself if you're interested. And I'll try and debug this and figure it out, and I'll send you an email once I've got it sorted out so that you can share that with the community. But one last thing I wanted to share with you all is that, you know, Linkerd is an open source community. We have a Slack channel at slack.linkerd.io. I'm there under the handle Charles, so you can come say hi anytime and get your questions answered about Linkerd. These are my contact details, so you can find me on Twitter, GitHub, Slack, and my email address. So again, I want to thank you all. I will practice my Portuguese for the next one, I promise. I won't be fluent, but I'll practice. I really appreciate all of your patience as we go through these demos, and I hope that this was helpful in understanding larger service mesh concepts. I'm really disappointed that my demo didn't work out, and it's bothering my brain right now. So so yeah, if happy to answer more questions or anything.
Charles, was amazing. I learned a lot, and I will test this. I really appreciate this presentation. It's usually has problem with live presentations. It's not problem. The grading instruction that you showed to us, this communication was amazing, really amazing. Thank you so much. We don't have questions. I don't know if Nuno or Nuno is ambassador from CNCF and is watching your presentation. Nice to meet you. Nice to meet you here, Nuno, my friend. And he's a Windows guy, Microsoft guy. He works with Microsoft. He works with Windows. And I want to ask you if you have this kind of capabilities inside the Windows too. Linkerd, we can use. We have a client for Windows or something similar.
Yeah, so there's a distinction there too. So as I was going through all of the examples today, there's a Linkerd CLI, which is you use to interact with your cluster. So there is a Windows executable for that. The containers themselves, the proxies, don't run on Windows. because of the way that Windows networking works. I think it's NF tables. So it doesn't work the same way. Linkerd is all based off of IP tables. And so since Windows doesn't use IP tables, then we can't use Windows containers. But the CLI will run on Windows.
Great, great. Oh, really amazing. I appreciate it. Thank you so much. I will invite you again for another presentation. And this presentation is being recorded, and it will be available on our channel. I want to thank you so much for this time. It was amazing. Thank you, Bayan, and every team from Bayan for this amazing product like Linkerd. Thank you so much.
Thank you for everything. I really appreciate it. Look forward to seeing you again.
Yes, I will see you again. Thank you so much.
Okay.
Cristiano, come on. Let's go.